Hello students, so in our earlier lecture we studied about TM mode propagation and their formulas. Here we'll see the modal propagation of either TE or TM mode, or we'll see how the waves are being denoted within the waveguide. So let's recall the TE mode equations that we derived during the solution of TE mode. These equations were obtained. I have just rewritten those equations, and in our earlier lecture we saw that the dominant mode for rectangular waveguide is TE10 for A greater than B, and TE uh, if A is less than B, then the dominant mode will be TE01. Means what will be the cutoff frequency that decides the dominant mode, or the order in which the waveguides will enter into the waveguide, or it depends on the dimension of waveguide. As you can see here, if A is greater than B, the dominant mode is this, and if the dimension is A less than B, then TE01 is the dominant mode having lowest cutoff frequency. So the order in which the modes will enter into the waveguide depends on the dimension, and the second thing, it depends on the material through which they are being propagated. Okay, for a mode to propagate within the waveguide, what was the condition? If the frequency of impressed signal is greater than the cutoff frequency, then those modes will allowed to be propagated within the waveguide. So there are numerous modes that could propagate within the waveguide. Now let's see the TE10, how the waves are being denoted in TE10 mode. TE10. So the equations will be obtained by putting m equals to 1 and n equals to 0 in the above equations. So Ex will become 0 because we have put n equals to 0 in this equation, first equation. Ex will be 0. What will be Ey? Ey will be only sine component. Cos component will become 1, so this Ey will become Eoy sine m is equal to 1, so this is equal to pi x by a. X cos 0 is 1, exponential minus j beta g z. From equation number 2 we have put the value of Ey here. Ez is 0. Means the electric field component that will exist within the waveguide in TE10 mode is the y component only, which is having sign variation along x-axis. Sin pi x by a is here, so it will vary along x-axis, and it is a y component of electric field. Now let's see the magnetic field component for TE10 mode. Hx will be, what Hx will be, if we put m equal to 1 and n equals to 0, it will become Hox sine pi x by a cos 0 1 exponential minus j beta g z. Hy, what will be Hy? Hy will be 0 because sine 0, n is equal to 0. If we put n equal to 0 here, this Hy whole becomes 0. Hz, what will be Hz? That's right, this equation, Hoz cos pi x by a and cos 0 1 exponential minus j beta g z. Means we have only Ey, Hx, Hz. The variation of Ey and Hx is same, which is sinusoidal form, and the Hz will vary as cosinusoidal form. So from this equation, what you will see you are seeing that EY is varying as sinusoidal nature. So this is the rectangular waveguide which along x-axis and y-axis the EY component is varying sinusoidally. This is a half wave which will exist within the waveguide cross section at x is equal to 0. At x equal to 0, this is 0. Maximum will occur at x is equal to a by 2 if this dimension is a, and it is 0 at x is equal to a. Means the maximum electric field component will exist here, and then they will start to diminish. So maximum intensity will exist here in between, and they will decrease on either side of the middle part of rectangular waveguide. So this is TE10 representation. These solid lines represents electric field lines, and the magnetic field will be in x direction and z direction. X direction means x component will exist and the z component will exist. I am showing only the front view here. The magnetic field lines will be around these closed paths, will form a closed path around electric field lines. So they will be shown like this. So number of half waves that exist within the waveguides are number of half waves of electric field that will exist within this waveguide is 1. One half wave will exist along x-axis. So 1, and number of half waves along y-axis is 0. This is TE10 mode. So when we talk about TE20 mode, means there will be two half waves that will exist along x-axis. Means if this is the waveguide that we have, number of half waves along x-axis for TE20 mode. Number of half waves along x-axis, m is equal to 2, n equals to 0. Means along x-axis there will be two half waves and 0 half waves along y-axis. So there will be two half waves. This is TE20 mode.